Welcome grade 8. In today's math video, we're going to begin talking about enlargements with similarity. And in order to better understand how we can make an object larger or smaller to fit a certain scale, we have to understand scale factor. Now, scale factor is by what factor or by how much is something being resized from the original. And is this something that is being resized much larger, or is this something that's being resized much smaller? What you'll notice is that when we're taking a look at numbers for scale factor, we will typically talk about scale factor as being either greater than 1 or less than 1. If we have a scale factor that's greater than 1, that means it's getting bigger. Maybe it's 1.5 times the original size, or 10 times the original size. If it's less than 1, that means that it's getting smaller. We might say it's half the size or 2/3 the size of the original. And so we're going to introduce this new term here called scale factor. And we have actually a really simple formula to solve for scale factor. And that is that we're going to compare the length of a side of the image, and we're going to divide that by, or compare that to, the length of the corresponding side of the object. If you're getting tripped up by the wording, don't worry too much about it. Basically, what we do is we get a side length of the object and compare that with the side length of the original. The object or image, sometimes we call that, with the original. It's important to remember that we have the object or the image on top and we have the original on the bottom. And it's also important that we are comparing corresponding side lengths. So, for example, if you're taking a look at two rectangles that you're comparing, and if you are comparing the length of the top of the rectangle, the top line, make sure you're comparing that with the length of the top line in the image of the rectangle, so that you're going to get a proper scale factor here. Now, when we talk about originals, we can talk about either reductions or enlargements. So let's take a look at kind of an original shape here. Let's say that's our maybe slightly poorly drawn shape, but that's our shape. We're going to call it A, B, C, and D, and we're going to say that this side length here, AB, is 2 centimeters. This is our original image. And if we were to take that image and we're going to make it much smaller, we're going to still keep things relatively the same. So, in other words, if you're following along with some of the terminology we've been using, we are making similar shapes, not congruent shapes, because the side lengths aren't equal, but all the angles are going to be equal. And so this is the image of A, of B, of C, and of D. Just remember that I put a little tick by it, just to show that A matches with A, but this is kind of in the new image of A. So it's not the original, it's in the image of A, so that's why we put the little tick there. If I make another image of A, B, C, D, which I'm going to over on this side, I'm going to put 2 lines next to it just to show that although it's still connected with A, it's different from the original and it's different from this image. So it's just kind of in math, it's one of the ways that we use to help understand that. So this is going to have a 1 centimeter side length here. So when we're going this way, this is called a reduction. We're getting smaller in size as we go to the shape over on this side. And to figure out scale factor here, I'm going to take the length of the side of the image, AB, 1 centimeter, and I'm going to divide it by the length of the corresponding side, 2 centimeters over here. And if I divide them, I get a 1/2, 1 over 2, or 0.5, whatever you prefer. And that's my scale factor of the reduced image. It is half the size, or it is reduced by 1/2 of the original value. If we go the other way here, I'm going to try drawing another shape. Again, I'm going to label this here. This time you'll notice that I'm putting 2 ticks by everything. That's to show that, again, they are corresponding angles, but it's in a different image. It's different from the original, different from this one here. When we go this way, you can tell, hopefully, that it is much larger. This is called our enlarged image, whereas this was our reduced image. And this one, going this way, we call this an enlargement. It's making it larger, enlarging the shape. And we're going to give a side length here of 3 centimeters. Now, in order to figure out this scale factor, again, we take the side length of the image, even though it's bigger, the side length of the image, which is 3 centimeters, and we divide that by the side length of the original, which is 2 centimeters. When we do that, we end up with a scale factor of 3/2, or 3 out of 2. For those of you who feel like you understand this really well, you can stop this video here, work on your questions. For those of you who'd like to stick around and to hear a bit of an explanation as we go through example 10 and 11, that's what we're going to be doing next. So let's take a look at example 10. I've drawn a crude drawing of example 10. Now my boxes are going to be different than the actual image boxes. So I'm going to be talking about it as if it's the example in the textbook, using those proper boxes. I did draw it to scale. It's just I didn't use the same size boxes. If I did, it would be very, very large of an image. So just keep that in mind. I'll explain that as we go through. In example 10, it shows that you have 2 similar figures. Now this one's a little bit different because figure A, B, C, D, E, F, G, A, so the bigger one with all the ticks next to it, that is the enlargement. So that is the image, we can say, of the original shape A, B, C, D, E, F, G, A, back to A. Now this one, you'll notice I have a tick next to it. Actually, this point acts as both A with a line and regular A, and that's because they overlap. It's an enlargement from that particular spot. We're going to be talking about those sorts of questions a little bit later on. How do we figure out where something is enlarged or reduced from? But for now, don't worry too much about that. The only thing that we really care about is comparing these two. So generally we want to, it doesn't matter which line we choose, we want to be able to compare 2 side lengths. So in this one here, our textbook has us comparing DE and DE. Remember that this is our image, and so our image goes at the top, so we're going to have DE at the top, and we're going to put that over DE on the bottom. You'll notice this one has the ticks, it's the image, this one does not. In the textbook it tells us that DE is 16 units over this DE of the original shape, which is only 8 units. When we divide those two, we figure out that we get a scale factor of 2. Now, you don't have to actually use units. We don't have to say 2 units. We don't have to say 2 centimeters. It's just a scale factor of 2. It's just a number that we're going to use. It doesn't matter what unit of measurement you're using. It's scaled up 2 times. And that's about it. In other words, this image here of this Christmas tree type shape is twice as large as the original image, which is inside. Let's take a look now at another example. Again, if you're following along in the textbook, this is going to be example 11. And this one gives us information about the Statue of Liberty. It says the Statue of Liberty on Liberty Island, New York, is 305 feet high. Its miniature replicas, which are sold as souvenirs, are made using a scale factor of 1/732. Find the height of such a replica. So this one's interesting. We're having to rearrange our question a little bit. We know that scale factor equals the length of image over length of original. I just kind of simplified it that way. But this time, we don't know the length of the image or the length or the height of the replica. So that's kind of our x, our unknown. Our length of the original, we're told, is, or height of the original, 305 feet high. And we're also told the scale factor of 1 over 732nd inches. So we're going to have to do a little bit of things here. Now, what's nice in this textbook is it doesn't really differentiate between metric and imperial. It has us learning both. So for those of you who don't know, this is given to us in inches, or we're asked to find the height in inches, but this is given to us in feet. So we do have to do some converting here. For those of you who don't know, to go from feet to inches, we just multiply that by 12. So when we have 305 feet, we times that by 12. That'll give us the total amount of inches that makes up 305 feet. So if you were to plug that quickly into your calculator, 305 times 12, you'd figure out that that's 3,660 inches. Now that we have that piece of information, we can start working to solve the rest of the questions, start working to solve for x. So if you remember, in order to get x by itself, we multiply. We now have 1 over 732 equals x over 3660. We multiply everything by 3660. That's the opposite of divide. So you're left off with x equals 3660 divided by 732. Right? We just times that on the top there. And if we were to divide those two things out, we would figure out that that is a 5-inch replica of the Statue of Liberty, using a 1 over 732nd scale with a 305-foot original. So there's a lot that we had to do there, but we were able to take this basic formula and rearrange to solve for what was missing. And now you're going to do similar things in Try It 10 and Try It 11. Try It 10 is very similar to Example 10 that we just did. Try It 11 is very similar to Example 11 that we just did.